Next section, type of the problem. For single pipe flow with a uniform flow, there's three choice. The first is we have to already have the pipe, so we have to find head loss given the size and the type of the pipe. And the second, what is the flow rate? We identify flow rate given the pressure head, size and type of the pipe. And third one, we have to decide the sizing and the pipe. So we have to find size of the pipe given the type of the pipe and the other hydraulic parameter. And for the explicit equation for H loss, Q, and diameter, for the if we use the programmable calculator, Swami and James developed the explicit formula to compare to the Moody diagram. Okay, this is equation for friction factor is a function of the relative roughness and real number. Okay, and this is Q is function of diameter, head loss, okay, and relative roughness. Okay, just put the friction factor in equation Q. Okay, the next topic is the water hammer. We have to understand this phenomenon. We call the hydraulic phenomenon because very important for operating the pipe flow. In this case, this means the pipe pressure is rapidly in change, both increasing and decreasing from a normal pressure for the fluctuation of the pressure wave. Okay, and because of the water hammer abruptly change of the flow velocity from suddenly closed water gauge, momentum of the wave is converted to the impact force on the gate. Okay, and the pipe wall. If this force is large enough, the pipe can be explosive. That is very important. If it's large enough and serious damage to the pipe system and equipment. So we have to learn about this water hammer. Level of damage is depend on the strength and the elasticity of the pipe, flow velocity, rate of the change of velocity, pipe anchoring. Pipe anchoring, you can look at the next picture. That is the it look like a pipe anchoring to attach the pipe to the support to the foundation. And preventive equipment of the water hammer. Okay, we in case of the crossing pipe, we start to develop equation for water hammer. Actually, we can start from Newton law. Okay, from this, and m each time acceleration is mean v2 at v1 divided by delta t. Okay, in this case v1 v2 is v1 initial velocity, v2 is the end velocity. If we apply it to this pipe is at point 1 and point 2. We close a gate on the point 2 and we close the gate. So in this case, F is equal to M. Oh, sorry, small area, so difficult. So we can write somewhere here. F equal to M, because V2 is 0, so we only have only V1 by delta T. Okay, and mass, the volume of the flow is equal to area times the length. In this case, mass is equal to rho times volume, and equal to rho times volume is equal to A times L. So from this delayed equation, we can come up to this equation. Force is equal to rho A L times V divided by T. Okay. can see that this is we call the fluctuation of the wave. This for the water may create the water waves, okay, and this wave can be fluctuation like this, move to the left and later on move to the right. Increase and decrease of the pressure along the distance. And if we divide the force divided by area, so that is pressure. V sub U is a pressure wave. Velocity. And V is water velocity. In case of the steel or cast iron pipe, the relationship between stress strain is linear. So its maximum pressure is used. We can use this equation for the find the pressure, and this can write is a ratio of the modulus of the elasticity of the water divided by modulus of elasticity of the pipe times the diameter of the pipe diameter divided by thickness of the pipe wall. You may learn this from mechanical material course. And this equation for pressure wave velocity. See that the main parameter is the K over E, or modulus of elasticity between water and pipe material. That is the steel cast iron. Okay, so it means for steel cast iron is small, but for the absorption is higher. And the critical time TC is equal to 2L divided by pressure wave, but actual time for the valve closing TA is more than critical time. But actual pressure is a function of the actual pressure from the water hammer PA. It's also the function of a decrease is function of the TA. Okay, so it's come from actual pressure is ratio between TA and TC and TA. Okay.